Hi folks, my name is Vamshi Komaneni. I'm a group product manager on Azure Storage. We've been learning about the different services in the previous talks. In this last talk of Storage Day, we're going to cover how to integrate Azure Storage with your applications. We're going to cover a few different patterns. First, we're going to talk about containerized workloads, which is a very common pattern for building applications nowadays. We're going to talk about how you can use storage to enhance your web and mobile applications or build new cloud-native applications. And we're going to cover serverless computing and how storage can play a foundational role in those applications. So you've learned about these different services, Azure Disk Storage, Blob and Data Lake Storage, files, and NetApp files. We're going to touch on each of these services and how they integrate with applications. But this talk is going to be mostly focused on the Blob and Data Lake Storage, which is your canonical service for building applications. So that said, let's just dive in. We'll start with storage for containerized workloads. And for this section, I'm going to ask my colleague Vaibhava to talk us through it. Go ahead, Vaibhava.
Thank you, Vamshi. We're seeing a significant rise in the deployment of container-based workloads, both in the cloud as well as on-premises. Kubernetes has been the leading orchestrator when it comes to containers and offers portability, extensibility, as well as self-healing capabilities that is critical for customers running at scale in the enterprise for their production-based workloads. Azure offers you a number of different ways for you to run these container-based applications, including Azure Kubernetes Service, Azure Red Hat OpenShift, as well as Azure Container Instances. AKS automates the deployment management and operations of the Kubernetes control plane and simplifies cluster management, upgrade, and scaling. ERO offers these fully managed functionality with Red Hat OpenShift, and Azure Container Instances allows you to elastically burst to virtual nodes in your AKS clusters. Now let's learn about stateful applications. Now, we've seen a significant increase in the number of customers that are running stateful workloads, and these could include high-performance applications like databases, like MongoDB and Postgres. This could also include big data applications like Cassandra and Elasticsearch, as well as tooling like CMS environments and/or CI/CD systems like Jenkins. Now, when it comes to the stateful architecture, Kubernetes is really the orchestrator that's managing different resources like pods, as well as deploys containers on which the applications run. On the data side of things, you can use either storage, which comes in the form of block or file storage, as well as managed databases like SQL and MySQL, all that are exposed to these containers using a common storage interface, which is called SCSI, or Container Storage Interface. Now in Azure, you have three different ways in which you can use storage with these container-based applications. These include Azure Disk, Azure Files, as well as Azure Blobs and Data Lake Storage. Azure Disk Storage provides you persistent performant block storage that can be used for these container-based applications. And this comes in different types, including standard, premium, as well as ultra disk. And these can be used for different workload types, including databases, caches, or CI/CD systems. Azure Files provides shared storage that can be accessed concurrently for multiple different pods. This is exposed using SMB or NFS options, which is in preview. Now, Azure Files works great for shared or user workspaces, CMS-based applications, as well as AI/ML. Now, Azure offers a unique capability of Azure Blob and Azure Data Lake Storage, which can also be exposed via a file system to these Kubernetes environments. This can be done using BlobFuse as well as NFS version 3, which is currently in preview. This works great for analytics-based workloads as well as AI and ML. Now that we've learned about the different storage types, let's jump into a customer scenario. DNVGL is an organization that establishes and maintains technical standards for construction and operation of ships and offshore structures. The Maritime Production Group within DNV has set up an innovative machine learning factory, which uses a plethora of different Azure services. This runs with Kubernetes as the core infrastructure layer and uses Azure Files for concurrent access from multiple pods in the environment. Now that we've seen a great customer example, let's jump over to a demo. Here we have a Kubernetes environment that's deployed on Azure, and it's using Kubernetes version 1.20 and has a single node pool. Let's jump over to the storage. First, we're going to look at the storage classes. Here you see different storage classes for Azure Files, Azure Disks, as well as Azure Blobs with NFS. Next, let's jump over to the persistent volume claims. You see 3 here for the different storage types, and these are configured with the premium version of Azure Disks, Azure Files, as well as Azure Blobs. Next, let's jump over to workloads. And here we want to look at the pods and look at the default namespace. Here you see that there's an Nginx as well as a Redis pod. Let's look at the Nginx pod. Here you see that there's a single container and a volume that's configured with the Azure Disks Premium persistent volume claim. We also have the Redis configured with the Azure Files Premium volume. Now that we've seen the setup, let's jump over to the command line and actually learn more about this environment. First, we're going to look at the PVCs. We just saw them through the UI, but let's take a look at that through the command line. So we use kubectl get PVC, which gives us the list of the different PVCs or the persistent volume claims. We have this for Azure Disks, Azure Files, as well as Azure Blob. Here, we're going to look at a scenario where you may lose your application and have to bring back the volumes from a snapshot. And you could do this through CSI. So let's take a snapshot. We can look at the snapshot object by doing kubectl get volume snapshot. So let's try that. And there you have it. You see the volume snapshot that was taken with the persistent volume claim, which is the Azure Disk Premium SSD. Now we can actually stand up a new volume from this snapshot by actually using the CSI restore options. So let's take a look at that. Here we apply the restore, and that will create a net new PVC for the restored volume. Let's take a look at the list of PVCs again. Here we have kubectl get PVC. And this will give us the list of PVCs. And directly you see that there's a net new PVC called the Azure Disk Snapshot Restored. And it's in pending state because this is waiting for the pod for which it'll get bound. Now let's stand up a net new Nginx application using a new pod spec. Here we could do this through the Kubernetes native APIs. Now that we've set up a net new Nginx environment, we can now look at the persistent volume that actually gets created. Let's do kubectl get pods. Here we see that we previously had the Nginx pod and the Redis pod, but now we have the Nginx restored, which is a net new pod that is in creating state. When we do kubectl get PV, we can actually see the persistent volume, disk volume that was created. And when we do kubectl get PVC, we can now see that this is no longer in pending state and it's actually bound to the application. So here we saw taking a snapshot of an Azure Disk volume, recreating a volume from the snapshot, as well as mounting it back to the Nginx application. Next, let's take a look at Azure Files. Now we looked on the portal at a Redis pod that was mounting an Azure Premium file. Let's take a look at the storage class for this. Here you see a described storage class for the premium files. Here you can see that it actually uses the SKU name premium LRS, as well as uses a provisioner CSI. It is also configured with allow volume expansion as true. Now let's take a quick look at the PVC. So we do a get on the PVC. And here you can see that the capacity for this is configured to 100 gigs. Now, in my production environment, if I'm suddenly running out of capacity, I want to be able to increase this dynamically. To do this, I'll use the kubectl patch function to specify a new limit, which is 200 gigs. Now let's take a look at the PVC again. And this actually shows us that we've dynamically scaled up to 200 gigs. Not only that, if we look within the pod, we can actually see that this is now available on the mounted file system. And there you have it. You can now scale your Azure Files volumes dynamically using the Kubernetes native APIs with CSI. Now that we've seen how Azure Storage can be used in Kubernetes in action, let's learn about the partner ecosystem. We work with a number of different partners on Azure that integrate with Kubernetes as well as Azure Storage. These include storage management partners like Portworx and StorageOS, data protection partners including Kasten, Valero, and Rackware, as well as managed Kubernetes providers like GiantSwarm and Robin. Now let's learn about web and mobile applications. Back to you, Vamshi.
Thank you, Vaibhava. That was a great overview of storage for containerized workloads. Let's now switch gears and look at storage for web and mobile applications. Azure has a whole host of services to make building and running your applications easier. App Service is the fully managed platform for building and scaling your web applications. If you have full stack web apps built on Angular, React, and other platforms, you can use the static web app service as well. Many applications use CDN for global delivery of code and media, and you may want to use the API management service to build your application gateways. You can then enrich your services with our AI services for search, for language translation, many other services. You can embed location awareness into your applications or communication services for voice, chat, etc. into your applications. How does storage play into all of these services? Storage is the base layer that you load your code from, load your assets from, or that you accept data from users, applications, sensors, and process them. So let's dive into how that looks. The canonical service to be used from storage for your applications is Azure Blob Storage. It takes care of a number of things for you. It takes care of all the durability and availability concerns, gives you dynamic scale, takes care of all of the security and compliance needs, and it is very cost effective and scalable, regardless of whether you're running small applications that are used by a few hundred users or web scale applications that are used by tens to hundreds of millions of users. There's some features in Blob Storage that are unique for application authors. So let's talk about a few of those things. The first one is the premium blob tier. This gives you the lowest latency object storage in the public cloud. It's very important because if you have interactive workloads where a user is using your application and looking at and saving data, let's say video editing in the cloud, or if you're serving data to your users, you just want where users notice these delays and tail latencies, you can do much better with premium blob storage. If you're worried about application state and managing state and versioning, our point-in-time restore capabilities allow you to have all of that and more. You can roll back state at any point in the restore window and do so with just a few clicks. And lastly, we have seamless integration with all of those services on the previous slide, such that you don't have to do a lot of wiring and sort of taping to get these services to work together. All of these services natively interoperate with Blob Storage already. So let's dive into what kind of developer tools and what kind of patterns exist against Blob Storage. First, we have a simple REST API, and you can just directly use that to code against Blob Storage. We have a number of SDKs that give you the synchronous asynchronous APIs, fault tolerance, and are fully open source on GitHub, so you can start there and fork or submit community contributions if you want to improve the libraries. These libraries are available in .NET Core, Java, Python, Node, Go, C++, and more. On the tooling side, we also have AZ Copy, which is like RoboCopy for Azure Storage, the command line integration, PowerShell integration for scripting, and a tool called Storage Explorer that makes it very easy to perform your administrative tasks against your storage accounts. Let's look at the common patterns, and look at what you can do with Blob Storage in each of these. The first and most common pattern is just storing and serving data out of your storage account. If you have static data, you're going to use Blob Storage frequently as origin storage for your CDN. That's fully natively integrated. You can just kind of go set up your CDN in a couple of clicks from the storage account. And you can then use the combination of Blob as origin plus your CDN to scale very easily to millions of hits from all over the world. If you're building a corporate application, you have great security features like AAD-based authentication, turning off public access, key rotation, and all of the security and compliance needs that your internally secure applications need. So you can still use Blob Storage to build and serve those applications. Another very common pattern is you have applications or you have sensor data, and there's a lot of data coming in. Blob Storage has a key advantage over other frameworks where you don't have to build an expensive gateway service or proxy layer to receive this data and write it in. You can use our delegated authorization capabilities to have untrusted devices or sensors upload data directly to our front ends and have that data saved and processed from that point onwards. So you avoid this sort of extra and expensive proxy layer. We also provide DDoS protection by default, and you have advanced threat protection if you want to use these capabilities to understand when you're being attacked, or if you have malicious users trying to break into your storage accounts. Once the data is there, it's really about processing and enriching that data. Our multi-protocol access and the ability to sort of receive data on the REST API, use it with the NFS API that Klaus talked about, or the data lake storage capabilities to connect to a Databricks cluster or a Synapse cluster, really light up this capability of both real-time processing as well as post-processing, whether it's analytics or other cognitive services-based enrichment of your data. So let's look at a couple of customers who have used these capabilities. Chipotle, when you go to the Chipotle website today, you're actually served a single page application, and that single page application is coming off of a CDN for which the origin storage is Blob Storage. So it's not just the assets on that web page, it's the page itself is being served out of Blob Storage. And that's a kind of very straightforward but very capable and powerful, flexible use of Blob Storage to build and serve your web applications. Let's dive into cognitive search a little bit. That can allow you to build even richer and more capable applications. It's a managed search as a service solution that allows you to take data, crack it open, build these rich search index functions, and for key phrase extraction, for OCR, for semantic meaning. And the nice thing is it's fully automatedly integrated with Blob Storage, and you can just set it up to automatically scan your Blob Storage accounts as new data comes in and build these indexes. An example of a customer that uses Blob Storage in Azure Cognitive Search is PwC. They have a regulatory compliance archiving application. Data gets uploaded into Azure Blob Storage, and it gets processed by Cognitive Search. They use the existing Cognitive Search capabilities as well as have their custom machine learning models integrated with Cognitive Search to really build a flexible, powerful, and scalable compliance archiving application. All right, so let's talk about the last pattern, which is serverless computing. It's a very powerful and flexible pattern, and with a number of different services in Azure that make that easy to build these serverless applications. Azure Functions allows you to have this event-driven serverless platform and develop your functions in .NET Core, Node, Java, or Python. Logic apps give you an orchestration, sort of a low-code way of doing the same kinds of orchestration and workflows. Event Grid is a foundational service for serverless computing because it gives you the event routing capabilities. And if you need to do some more heavy lifting that the serverless environments don't allow, you can still spin up these dynamic containers with Azure container instances, similar to what Vaibhava talked about earlier. So let's dive into the pattern and how storage plugs into serverless computing. A very common way that serverless computing works is you have data as a trigger or an event. The creation of data then triggers, through your event router, your serverless runtime. In Azure, that typically happens by having data land on Blob Storage and have Event Grid pick up those change notifications and route data in a pub/sub pattern, sort of one to many, to either functions, logic apps, or other services. Blob Storage supports creation and deletion events, and you can filter to a subset of your storage account. So let's kind of go look at an example of how that would work. Let's say you have a video file being uploaded. You take the blob creation event from that video file, publish it, it's published to Event Grid. Event Grid in this example is routing it to two different services. One, it's routing it to Azure Functions, and two, it's dropping that in an Azure queue. And what's happening after that is Azure Functions is picking it up, sending it to the Azure Video Indexes service, which is one of our AI services that allows you to do frame-by-frame analysis. It's also putting that data in a queue, and a container instance is picking it up. For example, if you're trying to do custom transcoding of those video files. So in this way, you can have these very flexible one-to-many delivery of events from Blob Storage into these computational or transformation services and really enable the serverless pattern. Let's look at an example of how this pattern works with a customer. Cloud9 is an esports gaming company. They take video from these esports tournaments and game playthroughs and things like that, upload the data into Blob Storage, and then orchestrate a machine learning environment that analyzes and really kind of breaks apart these videos and looks at how they can get an edge. And that follows almost exactly the pattern I showed you in the example, where you have data arriving in Blob Storage, the Event Grid service routing it to the right functions or queues or what have you, and then the computation picking up from there. So you can see that you can build these very capable infrastructures and applications, just starting with that simple routing pattern. So with that, we're at the end of this talk, and I want you to kind of leave you with a few key takeaways. First, we have a very capable set of integrations with the container services, both across disks, files, and blobs. We are able to use Blob Storage to build these very scalable and secure applications. And Blob Storage is also foundational for any kind of serverless compute patterns that you have. Thank you again for taking the time to attend this talk and all the other talks on Storage Day. We'd love to hear from you. If you have any questions, please don't hesitate to email us at azurestoragefeedback@microsoft.com, and we're happy to help you build your applications or answer any other questions. Thanks again.